Okay, chi-squared question. We are shown a survey, boys and girls, whether they drink tea, coffee or hot chocolate. First question says write down the total number of students. So in this two-way contingency table, the rows, we could think about what the rows total up to and what the columns total up to. So the number of boys in this survey was 15 plus 15 plus 10 was 40. The number of girls was 10 plus 10 plus 30, which is 50. So in total, they asked 90 people. And we can check, because we could sum the columns, and it should add to 90 as well. So 15 and 10, 25, another 25 here and 40 here. So 50 and 40 is still 90. So 90 people questioned. Chi-squared test conducted at the 5% significant level. Write down the null hypothesis. So null hypothesis, H0, null, nada. There is nothing going on. They are independent of each other. Okay, one does not have a preference. One does not sway the other. So here we're going to look at the two variables. So gender, and we're comparing it with drinks preference. So if ever you're writing a null hypothesis, you need to include the two variables. And if it is the null hypothesis, it means that they are independent of each other. Gender is independent of drink preference, or vice versa. Drink preference is independent of gender. That means that whether you prefer one drink or another doesn't depend on whether you're a boy or a girl. Okay? So you need to use the word independent. We can't use correlated or related. I guess you could say not dependent on or not associated with, but really just think null hypothesis, independent. Using the graphical display calculator for the chi-squared statistic. Okay, so let's check if you remember how to do this. Chi-squared here, we need to be in the calculator, we need to go into matrix. We're going to create a new matrix, and we're going to have how many rows? 2 rows for boys and girls, and 3 columns for drink preference. So we're not including the totals here. So 15, 15 and 10, and then 10, 10 and 30. And we want to store that, let's see, we want to store that somewhere. I'm going to store it in C. You can store it wherever you want. Okay, so let's just check. If I type in C, it should give me that matrix again. Good. Okay, now I'm going to go to menu, statistics, stats tests, and then number 8, chi-squared two-way table test. Observe matrix, well, we put it in C, so press OK. And here gives me the table with the chi-squared value. So the chi-squared value is 11.025. So the chi-squared statistic here was 11.025. Okay. State the conclusion. The critical level is at 5%. The critical value is 5.99. So critical value is 5.99. Our chi-squared value is 11.025. So think of it like this. If this is our critical level here at 5.99, if our chi-squared value comes out higher than that, that's more than critical. That's important. That tells us that there's something funny going on and that the two variables are not independent of each other. Okay? If the chi-squared is less than critical, we're not so fussed. It probably means that they're independent. There's no funny business. But if your chi-squared value is greater than critical, then that's important because it means we need to reject the null hypothesis. So our chi-squared value was greater than the critical one, 11.025. So we're thinking, something funny going on here. They're not independent. So the conclusion is that gender is not independent. Independent of drinks preference, or vice versa. Or you could say is dependent on drinks preference. The reason we know that is because that the chi-squared value is greater than the critical value. And so what are we going to do about it? We're going to reject the null hypotheses. We're going to reject this idea that they are independent. They're obviously not. It's greater than critical. So you need to remember this really. Critical value. If it's more than critical, it's important, we reject. If it's less than critical, it's not so important, we accept.